A derivative can be used to find the slope of tangent and normal to the graph of nearly all the functions. This is done by using the definition of derivative of a function at a point being equal to the slope of the tangent at that point to the graph of the function. Consider the graph of a function y is equal to fx. Consider a point P whose coordinates are x1, y1. We draw a tangent at this point P, and perpendicular to the tangent is a normal, which is shown by the dotted line. The angle that the tangent makes with the positive direction of x-axis is phi. With just this information, we can find out the equation of the tangent as well as the equation of normal of this point P. If y is equal to fx is a continuous curve and P x1 y1 is a point on it, then the slope of tangent at P x1 y1 equals the value of derivative at that point. Consider the graph of a function which is shown here like this, the red colored graph, and consider 2 points A and B which are separated horizontally by a distance delta x and vertically by a distance delta y. If you draw a line AB passing through both points A and B, of course, then the tangent of the angle A will be the opposite side divided by adjacent side. So that gives us delta y upon delta x. And that value is also equal to the slope at the point A. Similarly, if we bring the point B very close to the point A, the values of delta x and delta y decrease so that they become almost infinitesimal. So delta y becomes dy and delta x becomes dx. And consequently, we obtain the slope of the tangent to this curve at the point A, which is again tan theta, as dy by dx. Like this, dy by dx at the point is equal to tan phi, where phi is the angle that line makes with the horizontal positive x-axis. Now that we have obtained the slope of the tangent to the curve, we also know one point through which the tangent passes. This is sufficient information for us to be able to write down the equation of the straight line that is the tangent to the curve at this particular point. This is called the point slope form because we know the coordinates of one point through which the line passes. We also know the slope of the line. So the point slope form is y minus y1 is equal to mt times x minus x1. mt stands for the slope of the tangent. Hence, the equation of the tangent is y minus y1 is equal to mt times x minus x1. Here, mt is nothing but the derivative of the function with respect to x at the point, which is same as tan of phi. So therefore, equation of the tangent can also be written as y minus y1 equals dy by dx at the point P multiplied by x minus x1. Now we come to slope of normal, and thereafter how to write down the equation of the normal at that particular point. We know that normal to a curve at any point is perpendicular to the tangent at that point, the way it has been shown here. If the black colored curve is the graph of the equation and the red colored line is the tangent. Then the blue colored line, which is perpendicular to the red colored line, is called the normal to the curve at that particular point. So if we know the equation of the function and we know the coordinates of the point at which we are supposed to find the equation of normal, then it is easy to write down the equation of the normal. A normal is perpendicular to the tangent at the point of tangency. So that's the definition of the normal. Now, as I said earlier, the normal is perpendicular to the tangent at the given point. And from straight lines, we know that the product of slopes of perpendicular lines is equal to -1. The very famous relation m1 times m2 is equal to -1. This holds only for the slopes of lines which are perpendicular to each other. Hence, we can write down the slope of normal to the tangent at the point P, x1, y1 as mn is equal to -1 times m2, which is equal to -1 upon dy by dx at the point x1, y1, which is also written as -1 by tan phi. Since the normal also passes through the point and we just found out the value of its slope, we are now ready to write down the equation of the normal, which is again written in the slope point form as y minus y1 is equal to mn times x minus x1. However, the value of mn here is different from mt, but it is dependent on mt.